All right. Thank you so much, everybody, for taking the time to join today. We are just getting started here. We are joined by multiple people, and I am just going to take a moment here to share my screen. And here we go. All right, everybody. So I am your host, Peter Bowman, and I'm joined today by several guests. I have to my left Vice President of Sales here at Robot Lab, Cedric Vaudel.
Hey, everyone.
Also joining us remotely, I have Maria Alejandra joining us from Bogota, Colombia. She will be interacting with you all today via the Q&A section of the chat. And then all the way from Norway, we have James Nixon. All right, thank you so much, everybody, for joining. Today, this is the second installation of Robot Lab's summer webinar series. Dive into your research with an underwater ROV. Today's webinar is brought to you by Robot Lab, Blue Eye Robotics, and a very special guest from the University of Tromsø there in Norway. Today we have a packed agenda, so we're really going to go ahead and just get into it. We're going to start off with an introduction to Robot Lab and our newly emphasized higher education vertical. I don't want to isolate any of you folks that may be here from primary or K-12 education. We are working with this equipment in primary education as well as higher education. Just a lot of the information that's going to be spit at you is going to be more relevant to higher education. But if after digesting all this information, if you have additional questions and you'd like to reach out to us, please do not hesitate to do so. We're also going to be talking about how underwater ROVs are being used not only in education, but we're also going to be talking about how they're used in the real world as well in professions, many different professions. The Blue Eye team is also going to be giving an overview of their catalog, highlighting their flagship product, the Blue Eye X3, which you see over here to my left. And then I also mentioned that we have a very special guest today. Her name is Emily Venables. She's going to be talking about her experience with Blue Eye products and the Blue Eye X3 and why it's such a valuable tool there in Norway at her university. At the end, we will be doing a Q&A session with Robot Lab, and James will also be available to answer some of your questions as well. So we're very excited for that. With that, I'd like to hand the presentation over to Cedric Vaudel, who will tell you about a little bit more about Robot Lab.
All right, thank you, Peter, and hi, everyone. I really want to thank you for joining this session today. I really appreciate you and the time that you spent in listening to this presentation. So a little bit about Robot Lab. So again, my name is Cedric. I'm the Vice President of Sales. So I lead all the sales operations globally. I have worked with Robot Lab now for 7 years. The company itself has been founded in 2011. So we have been present for more than a decade. We are global, so we sell our products globally. However, we have a strong presence, obviously, in the US. Peter and I, are currently located in our headquarters in San Francisco. We also have an office in Texas, and we are growing and expanding, which is good. So we have been present for more than a decade in the academic sector, academic markets. So we work with a lot of research labs, universities, and that's historically how Robot Lab started back in the days. And from that, then we also started to work with K-12 schools and districts across the US and in Canada. And I believe that what makes us different as a company is that we have a strong expertise in robotics, and so based on this expertise, we are basically selecting the best of breed technology currently available. for clients, mostly academic institutes. So the idea here is selecting what's best or what provide the best educational value for research projects or for educational program. We also create curriculum. We create lesson plans and activities, which can be very helpful for teachers or educators that want to use the equipment to teach in a classroom different subjects. We are working with more than, I think this number is a little bit outdated, more than 32,000 schools and universities worldwide. So we do have a strong footprint. And basically, we have a two-way to approach a project. Number one is we do have a selection of products by category or type of robots or applications that you want to run. So that's one thing. The other approach will be basically for a university or research center that wants to create an entire lab. And so that's something that we started 3 or 4 years ago. And the idea is basically for us to design an entire lab from A to Z. So the way that our labs work basically is that we are going to go through a qualification of your project, and we're going to ask you several questions, such as what kind of program are you running, the age group of your students, what kind of research are you doing, as well as is there a particular type of equipment that you want to use, or a specific focus or subject that you want to focus on in the curriculum. And then out of these questions, we are going to basically offer you a set of different stations, and each station will be basically focusing on one particular area for curriculum. So it can be Industry 4.0 using robot arms. It can be humanoid robotics. It can be smart transportation. It can be green energy. And obviously, it can also be a station around underwater machines and robots. And obviously, we'll have an equipment, a platform to present to you in a second. But this is the idea of the lab, is basically creating an entire immersive learning experience for your students. So it doesn't have to be educational. We're also working on the completion of research labs. We're also working with companies that want to do research and are creating a new lab around like AI, for example. So that's basically what we do. You provide us a room, we come on site, we provide all the stations, all the equipment, the robot, the computer, the furniture, and I would say that the lab done by Robot Lab is very different in the sense that it's very futuristic, very innovative, using the best of breed technology currently available, all into a turnkey solution, basically. So we come on site, we do all the installation, we do the training, and obviously you will still have access to our curriculum and also ongoing support. So this is about the lab. We are working with the biggest player out there, from SoftBank Robotics for the human robotics business line to Blue Eye Robotics for the underwater robots. And that's basically when I'm going to ask Peter to go for the next slide.
Absolutely. And thank you so much for all of that information, Cedric. Yeah, we're basically just kind of elaborate on what Cedric just said. We're here to provide you a platform agnostic turnkey solution, right? And in order to provide that, we really have to partner with the best, but not just the best, but the best companies that provide a variety of solutions, right? So Blue Eye actually has an entire ecosystem of offerings centered around underwater ROVs. And this is why we chose them to kind of expand our catalog into this underwater robotic space. Blue Eye Robotics is the newest partner for Robot Lab. And so this actually marks the North American launch for the Blue Eye Robotics brand for education and research. And just to kind of, make it a little bit more broad, just about ROVs in general, right? We have, these things are being used everywhere now, the industry is only growing and getting bigger because people want to see what's underneath the water, right? And we can't always dive. Diving equipment's very expensive. Depending upon how deep you dive, it's also very dangerous, right? So it's much easier, much more practical to send an underwater ROV into this type of space than a person. Not only that, but when you have an underwater ROV with a camera on it, such as like all the Blue Eye underwater drones do, you're able to record that footage, and as opposed to somebody being underneath the water and kind of coming back up to the surface and talking about what they see, you're able to see what the robot sees, right? And you're able to pause, rewind, zoom in, everything that this drone is looking at underneath the water, and you get very, very valuable data this way. ROVs are being used both professionally and in industries such as search and rescue missions, fish farms, cruise lines, oil industry, etc. And they're also being used in university research labs like marine biology centers and classrooms. I spoke to a high school superintendent recently, superintendent of a school district recently, who wants to put these drones at the high school so that students can take field trips and see for themselves what's underneath the water. That's why I touched on earlier that while a lot of this information is being geared towards higher education, there is use case in primary education as well. With that being said, I would like to hand today's presentation over to our Blue Eye team over in Norway, where we have two people who have participated in today's webinar, one of which is going to join us live, Jay Nixon. He's the International Sales Manager. He has also recorded a demo with Tron Larson, the Senior Technical Sales Engineer over at Blue Eye Robotics. And with that, I will send today's presentation over to Jay.
Hey, thanks a lot, Peter. We really appreciate the opportunity to engage with an audience of people that will benefit from robust tools that are easy to operate, easy to maintain, and intuitive to drive. We truly believe that low friction access to what's below the surface is what is needed in a host of industries and in a host of use cases, not the least of which is environmental research. We believe that the more engaged you are with the ocean, the more apt you are to protect it. The more you study it, the more you learn, the better off this world can possibly be. And so we took on that task head on and made a suite of underwater ROVs that really can help bring what's below the surface above. And really, it's a data collection tool, and we're super excited to partner with Robot Lab. As we're Robot Lab's newest partner, so is Robot Lab our newest partner, and we're really glad to be on this webinar and have this opportunity to talk about what Blue Eye is. Because we're a team of about 20 people. We speak about 8 different languages, and we love what we do. We're passionate about this stuff. The guys and gals who built the first robots are still with the team today. So if you need to get a hold of somebody, the chances are the guy or gal who designed that part of the robot is still with us and ready to chime in. So we believe in the mission of Blue Eye, and we believe in what our customers do with the robots. So with that, I'll give you a little presentation about us, who we are, our technology, because that's important, and then also our products, because ultimately, I'm not selling you a robot. I'm selling you an opportunity to gather data, really an endless possibility to collect meaningful, real data that can be actionable. So allow me, in the famous words of every meeting these days, share my screen. All right. So we're Blue Eye Robotics. We're your eyes below the surface. That's what we hope to be. In terms of the underwater ROV market, there are what we call hobby drones. These are things that you can purchase inexpensively from places like Amazon, maybe even Walmart these days. And then on the other side, we have working class ROVs. Those are hundreds of thousands of dollars, take multiple people to operate, are the size of small cars. And in the middle, we operate in the inspection class ROV market. That's class 1 and 2. We are about 10 kilos in air. So one person deployable, one person operation. We work with a host of names you've probably heard, both universities and private industry, also in the aquaculture industry, to bring these tools to market and to people that need them. Blue Eye Products and the ROV system, we believe that the hardware and the software must marry up. They must be a cohesive unit. I like to joke that I'm in the software sales business, even though I'm a ROV salesman, because I know that ultimately it's the data that you collect that is the prized possession. So the way the ROV system operates, it's pretty simple. We have the ROV in the water. We have a tether to the surface. That tether has two purposes. One is to provide control to the ROV, and one is to supply the video and stills back to the surface. You connect that using a smartphone or a tablet. We are iFriendly, Android friendly. We're agnostic when it comes to platform, so no need to get a new device to operate this. Anyone with a cell phone can operate it through the Blue Eye app. And then we ultimately use a gaming controller. Gaming controllers are intuitive to use. They're very inexpensive, and most people have some experience with gaming, and more they have more and more experience. So for ease of use, we went with a gaming controller to ultimately drive. We're a mechanically stable design, which means we have ballast in the bottom and buoyancy in the top. For hundreds of thousands of years, human beings have been walking upright with their head on top and their eyes facing forward. That's how your brain thinks. That's the spatial awareness that our platform brings. You can't pitch the drone, you can't roll the drone, which leads to some really good footage, which is ultimately what we're looking for. In terms of maneuverability, we have 4 thrusters, 1 vertical, 1 side to side, and 2 push pull. So really drives more like a helicopter than a plane. We also have a few built-in features that make operating this ROV easy. And when I say easy, I mean 12-year-old. I have a 12-year-old stepdaughter. She can operate it. Auto depth, auto heading. Auto depth, simply get the ROV to the depth that you want using a pressure sensor. We lock in that depth. And then an auto heading using the magnetic compass to give you auto heading. So now all you're doing is compensating for current. You are now at the depth of the item you want to study, and you are now facing it. It's your job to compensate for the current. All of the software and all of the apps are developed by our team. So in terms of apps, we have the Blue Eye app available in the App Store or on Google Play, and also the Observer app, so that multiple spectators can dial in to the dive on site and see what the operator is seeing real time. That's a benefit when you have multiple people that need to get in on the action and maybe not a budget for a dozen drones at one time. So it allows everybody to kind of enjoy the experience and see what the operator sees. All of our updates are done through the app. There is no need to plug in your machine. All the updates are done directly through the app. And as Peter mentioned, we also stream live over Teams. So we can do that in a number of ways. The most common way is just over typical cell phone reception, 4G, 5G. Particularly helpful when doing some kind of inspection that needs some external input. So rather than recording the video, sending the video, getting it all back and forth, you can just dial that person directly into your dive on a Teams meeting and go from there. We support Teams because we support Microsoft products and applications. You can use Google Meetings, you can use Zoom, you can use GoToMeeting. All those things work, but we just promise to always support Teams. And then after you're done, you need to have some sort of reporting. That reporting can take many shapes. There is some built-in reporting functions right in the Blue Eye app. Those will make simple dive reports, geo-reference location of the topside unit, depth of dive, length of dive, any pertinent photos or video, exportable as a PDF or a Word or a CSV file. All of that information is also customizable into your own report. So if you have a Word template report that you want to use, feel free. If you have some sort of data management system that you need to feed this information into, by all means, go for it. If you're trying to create a 3D photogrammetry project and you need the CSV raw file to send to your software, go for it. It's your information. You should be able to export it any way you want to. In terms of our host of products, we have Blue Eye Pioneer, Blue Eye Pro, and Blue Eye X3. Today, we've chosen to highlight X3 as it's our newest model and the one with the most applications that we feel will fit this demographic. And so if you want to know more about the other models, feel free, click through our website, contact one of us. We'll be happy to run you through them. In terms of the way the drone looks inside, all the drones carry the same chassis with a few simple modifications, but we have a sealed aluminum housing with no penetrations through the watertight barrier. That allows us to have a robustness that is not found in most competitors in this field. Again, we're mechanically stable. So part of that is the battery being on the bottom, allowing for some ballast to keep that mechanical stability. Thrusters are self-changeable. They take between 15 and 30 minutes to change a thruster should something go awry. Blue Eye X3 opens up endless possibilities with 3 guest ports. Those guest ports handle a wide variety of protocols, multiple communication protocols, multiple power out protocols. With custom Blue Eye smart connectors, you don't have to flash the drone. You don't have to reset up your controller. You don't have to change the app. When you connect an accessory to a Blue Eye X3, the information is inside of the smart connector and it automatically updates the control app to configure to those settings. So if you hook up a gripper, you're going to get gripper controls. If you hook up a sonar, you're going to get sonar controls. If you hook up a DVL, you're going to get DVL controls, and you can get combinations of those controls as well. Also of note is a full CE certification. So for those of you who have searched products, a CE certification is something that carries a lot of weight. We have thoroughly tested these products and we stand behind them. As we talked about, the guest ports open up for a lot of possibilities. So, if it's under 20 volts and reasonably sized, we can probably power it and move it through the water. Those guest ports allow for the accessories that we talked about. And really, we say it's endless possibilities because we look to you to tell us what you need to get onto this ROV in terms of sensors, in terms of tools. We don't make these things and throw them out into the world and hope that you adopt them. We are a collaborative group of people that want your input because it helps us help you do your job better. We talked about the Blue Eye smart connectors. Those things are integral to the plug and play nature of our system. We want this to be easily operable. We want it to be a simple process. We don't want you to have to be a robotics engineer to operate this and collect reasonable images and good data. So that being said, plug and play is the way to go. External equipment. I'll go over a couple of these briefly, but I think that you all who are watching know which accessories are probably applicable to your field. So hosting a whole suite of sonars, from simple ping sonars all the way up to 3D scanning sonars. Navigation equipment. GPS doesn't work underwater, and if you need to have some referencing, we need to come up with a way to do that. So there are a few systems that will allow that. In terms of sensors, we have ultrasonic thickness measurement built in. We have cathodic protection built in, cathodic potential measurement built in. We can offer a number of grippers, extra cameras, extra lights, whatever you need to get the job done. The external light and the external camera are particularly helpful when trying to survey something in a high current. So that way we can keep the ROV hydrodynamically pointed into the current and then look perpendicularly with our external camera. Also particularly helpful when you have a gripper attached so that maybe you can get a good bird's eye view of the thing you're trying to grab. We have everything from simple open and close one-axis grippers to multi-rotating, multiple end effector grippers. It really just depends on the job you need to do. We'll supply you the tool to do it with. As we talked about, GPS doesn't work underwater, so we have to come up with a few ways to work around that. We've partnered with a company called Waterlinked, another Norwegian firm. to provide georeferencing information. In essence, strap the transponder onto the ROV, drop the antenna overboard, and then there's a series of technical things that go on to give you some relative position. Also, a water-linked DVL, a Doppler velocity log, gives you distance, distance and time traveled. So it gives us a way to track an area that we've been, and also maybe even more importantly, get back to that area at a future date. The KMZ, KLZ files that come out are easily overlaid on top of any maps program, simple Google Maps. Also, a DVL allows us to get an altitude, an auto altitude. So we talked earlier about an auto depth that's done with a pressure sensor, but that doesn't give us information relative to bottom. So if we want to do a long sustained survey that gives us good, consistent visual images, then being the same altitude off of the sea floor is a very valuable thing. Also allows for things like position hold. So we can simply lock the ROV in place with the DVL and take your hands off of the controller. The thrusters will fire in the background to keep that ROV in place. We talked about sonars. Again, a whole host of sonars from very simple to very complex. We believe in offering multiple product lines to people that have multiple, have different needs. And so, you know, if you have to have 3D scanning sonar, we're going to provide that. If you need sonar just simply for navigation, then we're going to provide that. If you need to know more about the sonar options, just get in touch with us. We're happy to supply all that information. Multi-beam sonars are a particularly helpful tool when navigating in low visibility or zero visibility. So as we can clearly see here, the camera sees nothing, but just 10 meters in front, there's a full sunken plane. And you know, the picture on the right shows you kind of the size of that unit, right? It's a very small unit. It's smaller than the size of a tissue box, let's say. We believe that software should work for you. And so that's what we're going to talk about here for a little bit more. We believe that you should have access to the software development that we have put down. You should be able to build upon it. You should be able to learn from it. So we put together a great GitHub library. There's a full software development kit. It gives you documentation, again, full software library, example codes on how to control the various models. The SDK will enable, we say enterprise customers, we like to say aggressive customers, to write their own software and download that process, you know, and have that information and data easily available. The software that we develop, we talked about the Blue Eye app, we talked about Blue Eye Observer app. We also have a file transfer app that makes getting that data off of your Blue Eye and onto your ultimate processing device much easier. Full Blue Eye SDK, and then again, the Bluenix operating system, which is our own internal Linux system. Bluenix and Blue Eye file transfer are two things that we think are invaluable to those of you that are going to do more with this data than just a visual inspection. Again, we talked about a little bit earlier, 3D photogrammetry, using just simply the images and video from a Blue Eye and exporting a CSV file to third-party software. We use Agisoft. You can create some really stunning 3D models just with visual display. So we also think that customer support is something that you should be able to lean on. You should be able to get a hold of us if you have a question, if you have an idea, if you have a problem. So we offer introductory courses. We can do those live over Teams, or if you're so inclined, come here to Norway. We run a monthly introduction course, weather permitting, and we would certainly love to have you. In terms of service and maintenance, we give you a whole library in our help center that will help answer most questions, the most commonly had questions. And I encourage you, take a look at our help center. I think you'll be impressed. You know, in terms of marine research and education, we do a lot of work with UAT, with Intenu, with a whole host of Norwegian and more broadly Scandinavian universities. And so when you read something like Compared to Divers, X3 gives us more access, more data, make the surveys more efficient. It's a safer alternative when we dive under ice and in dark conditions. These tools are essential. they open up a new world for the students. And that's the key takeaway here is all of this is to say, we want to open the underwater world to students, to researchers. We believe that you should have the ability to see what's below the surface, and it should be easy. So, you know, I'm sure that you've watched this and you've thought to yourself, hey, I could use it for this, I could use it for that. You probably came into it with some preconceived notions of what you hope to learn or hope to see. But as this presentation has gone on, I hope it's also spurred on some questions about, well, hey, can I do this? Can I do that? So, you know, we have extensive history in mapping marine litter, monitoring coral reefs, inspections of all kinds of underwater areas. We like to say that putting a blue eye in the water is a zero risk opportunity versus putting a human in the water, which is a high risk opportunity. Collecting valuable data from under the sea, it says sea ice, which is a great application. Observe live animals. We have filmed all sorts of wildlife with this drone, and no wildlife to speak of has had any ill effects. If anything, most wildlife is curious of what this thing is doing in their environment. And so at the end, we say it's a sensor carrying platform because we really believe that the tools necessary to do this job are more than just visual, and we want to be the people who carry those sensors around for you in the water. I've talked a lot about our capabilities. I've talked a lot about our capacity, a little bit about our company. It's one thing to hear it. It's another thing to see it. So we pre-recorded a demonstration, and I'm going to play that for you now. So that way you guys can see Blue Eye in action. Just 1 second. As promised, here's a in-water demonstration. I am in our conference room, sitting comfortably in the offices, and I have Trond Larsen out in the Trondheims Fjord at Korsvika. He's going to put the ROV in the water and show you what we can do. It's all well and good to hear about it and see it on a PowerPoint, but it's another thing to see it live in the wild. And as we talked about, one of the great perks of our platform is being able to live stream over Teams, and you'll get to see that here. So Trond, take it away.
Thank you, Jay. As you can see, I'm here at Korsvika. It's just outside the city center. I have my drone ready to go down on docks. So I think I'll just get in the water. So I'll switch over to screen sharing and start the Blue Eye app. That way you can see what I'm doing. Can you see my screen now, Jay?
I can.
Then let's get out diving.
It took Trond about 2 minutes to get this out of the box and ready to go. So in the course of time that it takes you to pour your coffee in the morning, you can have this in the water.
Yeah, I came down here just a few minutes ago. Just launched the drone and connected to Teams. The Korsvika area is just outside the city. You can see here we have a bit of freshwater area here. I'm going to get the drone down so you can see where we are. The visibility will be even better when I get deeper down. I just want to show you the area. We have some wastewater pipes over here, so I'm just going to drive over to those for some research. Environmental impact from human interaction can be a big deal. So I thought going over to these pipes and just checking out those first, and then we'll see more about the kelp we can see here. You can also do some sampling underwater. Just to give you some input, you can see on the lower left corner, you can see the depth at 1.7 meters and the distance to the seafloor below. And I can easily drive around. I'm going deeper now to try to find the pipes. They're coming out from the structure here right behind me. The other things you can see on the screen, you can see I have date and time on top. I have a compass in the center on top, and then along the top line you have dive data from the drone. And on the lower left we have auto depth, auto heading, and that's kind of like autopilot functions, keeping the drone in one depth and in the one direction I'm looking at. So here we're getting a bit deeper. You can see the visibility is getting better. And I'll just start recording so we can go through what we see afterwards. See, already we're lucky we have some fish circled around above us. I got a really scenic view here.
And that's one of the things that we've noticed in our testing is that marine life doesn't really run away from our ROV. And if anything, it becomes curious and starts looking. I don't know why that is, but it is.
Yeah, here you can see the wastewater pipes coming up from the ground and going down to the deep ocean. There's often a lot of life around these pipes. We see both kelp and other marine growth on them, and we see fish living in and around them. Of course, if there was any damages to the pipes, we could clearly see it on the screen here. And you can also see this fish, it doesn't really care that I'm here if I don't get too close. This is a pollock, and I think I'm about 1 meter or 3 feet away from it. If I go down a bit more, I can tilt the camera up. No, it didn't want to get me too close to me. So you see, I can tilt the camera up and down to get the angle I want, depending on where you are. And I can just follow this fish around. The sediments you see in the water is just, we have a river close by, so I call a lot of freshwater runoffs here. But even without it, I can clearly see here, I'm not that deep. We have quite good diving conditions. If it was darker, I could turn my lights on. I'm going to show you some examples of that. But here, I just want to get really close to these hydroids here. See if I can't get a beautiful view.
And Tron, make sure you take a couple still photos for us there.
Yeah, so we have the option of making video recordings and also still pictures. So I can have the video recording going and I can still take a few pictures. All the pictures are stored on the drone itself in full HD, so it's quite easy to take out afterwards, either on my phone or a computer to create reports. I am live streaming this. All this is going through Teams. There's practically no delay. This way, if Jay saw something I didn't, he can just tell me to go back, go up, go wherever I want. Or if you find something you don't know what it is, I mean, is this some environmental problem or some animal or plant you don't know, you can connect a remote and just have some specialist connect on Teams and help you out with what it is, and if something you want to do a sample from or a photogrammetry model. Everything control on the drone is input based, so I can do really slow motion movement here. You can see I can get really close. I'm starting to get a shadow here, so I'll turn a bit of lights on. The lights are adjustable. And here you can see as the lights have a CR rating of 90%, which is the color rendition is 90% of what the human eye can see. So by turning on the lights, I can get the red colors in the ocean quite clearly out, and that can help me if I needed to do identification of this type of kelp or any of the other things you find, plants, animals. I'll speed up a bit and I'll go over to where we have more kelp forest. I think we will have a bit more life over there. So of course I have been driving these drones for quite a bit, but they are really easy to operate. I do a lot of training, onboarding with our customers, our users. and most people can quite comfortably operate this drone within minutes. I've had people picking up samples from the seafloor less than 5 minutes after touching the drone for the first time. Now, of course, some people need a bit more training time, but within an hour or two, most people can do pretty much what they need with the drone within the limits. The fish, you can see the fish is really interested, but they really don't care about the drone. I've been watching crabs and fish fight about food on the seafloor and not caring that I am here. And I'm not a fully marine biologist, but I think when the fish feeds right in front of you, there's a good chance they don't care that you're there. See this, it's a small blue mussel, but I try. It's a bit small, and I don't have the appropriate end effector to pick that up. If I was doing real biological sampling, we have different end effectors that you can attach to this gripper. So you have a soft claw that I would probably use if I were picking up any biological samples here. I'll try to pick up this, I don't know if it's a rock or a shell here. Getting the perspective right when you do this in the beginning can be a bit challenge, but because the drone is so quiet, so easy to operate, you really have time to just carefully go in. And I picked it up. I'll just speed up a bit more. And you can see I picked up, yeah, it was a rock. You see, I could quite easily pick up the rock, turn it around. If I had a basket down here, I could drop it in that, or I can drive it up to the surface to get this sample back. You can also see I'm down to 8.5 meters here. The depth rating of this thing is 1,000 feet or 300 meters. I've been down to those kind of depths, and I could still operate a drone quite reliably. And you can too. It's just a matter of a bit of training. So I'll just drop the rock here. I'm not a geologist, so I don't think it's really what I want to bring up. I just move a bit up in this kelp forest and see what we can find over here. Again, here you can see, due to shadows and the red light disappearing underwater, I can adjust the lights to get out the details I need in the pictures.
And our stream is a little wonky right now, but like Tron said earlier, all of the footage is stored in full HD on the drone.
Yeah, also on my screen, I have it practically in full HD on my screen. It's just sometimes Teams doesn't want to transfer all the video at once, but if you have 4G or 5G connection, you can really get the same quality you're seeing from anywhere around the world. I've done this remote diving all across the globe, diving from Norway with people guiding me from Hong Kong, Brazil, Houston. So it really is a very easy accessible tool.
Tron, is that a keychain down there on the seafloor?
Yeah, it looks like it. Well, let's do something good while we're here and pick that up, bring it home. See. So just finding the correct angle, turning on slow motion so I get a bit more control over the drone. Take a picture before I start picking it up. You see here, I'm just taking it really easy. There's no point of rushing this. The drone is really stable by itself. I don't want to whirl up sediments. It's not a lot of sediments here, but if there are sediments, you can just put on slow motion and you can operate really close to the sea floor without whirling any sediments. You see I'm starting to hit the rocks here. A bit forward, back. Maybe that's a loop I can get. I think this will be good enough. Just close the gripper here. Take another still picture. speed it up a bit. Oh, look what I got.
What is it attached to? Some kind of leader? Oh, maybe off a sailboat or something, huh?
I think it's actually something from a free diver. It's
All right. And at that point, we pulled it up, and it's now in our office, hanging on the wall of stuff that we've collected during dives. And I think the key thing to take away from that is he couldn't see that object while he was operating it because he's focused on operating, and also that's a smaller screen. But I'm sitting in the office, I could see it as clearly as you could see it, right? And the ability to have multiple spectators in is invaluable. We really thank you very much, Robot Lab, for having us here. We really thank you all, the people who attended, for learning more about what A, Robot Lab can do, and B, what Blue Eye can help Robot Lab do for you. We really welcome all questions. We welcome all feedback. That's how we grow. That is our business model, giving clients, consumers, customers the things they need to do their jobs every day. We're passionate, we're driven. If you can think of a scenario where this thing can go, let us know, because we sure would like to help you get there. And with that, I'll throw it right back to Peter. Thank you very much for your time.
Thank you so much, James. I mean, I can't stress you enough how impressive all of that is and was. And we are very passionate about what we do in partnering with our collaborators in education and giving them the tools that they need. And having a partner like Blue Eye that is so dedicated to what they do, a partner that's actually born out of a university, right, and knows what these researchers and educators need is as you mentioned, it's invaluable, and we're excited to embark on this partnership and spread the knowledge and spread the tools so that other people can spread knowledge, right? And just more to that point, I will again share my screen here. And as I mentioned earlier at the beginning of the presentation, we are joined today by a recording from a very special guest, Emily Venables. She's the head engineer at the University of Trosmo, and she has sent us a recording today to talk to you from an educator's point of view about what exactly you guys can be or should be doing with this type of equipment. And so we will go ahead.
Hello from sunny Tromsø
Sorry about that, everybody.
in northern Norway. My name's Emily Venables. I'm a technician at the University of Tromsø. I work within the Arctic Marine Biology department there, but my role is as an engineer rather than a researcher, and I look after all the marine robotics that we are implementing within the department. As a university, a massive benefit to the students that are studying marine biology is to be able to get a first eye view of what they're studying underwater. So without becoming a scuba diver, Blue Eyes make them able to see the organisms that they're studying and get a really good view of what they're looking at underwater. In the past, they've only been able to look at videos, what's been trawled up, samples that they can count. But now they can come down to the beach, they can come on a cruise, and they can have a live display of what they're sampling underneath them and how those communities interact. UIT recently has taken delivery of a number of Blue Eye ROVs, and we're trying to integrate them into the marine biology courses, into research projects. And my job is to enable people to use them. So the first thing I've done is set up a checklist, give people some basic tips and training, not really much more than is in the operations manual, but it's good to talk these things through with people, make sure they remember things like putting the connector caps on once they've charged the battery. But the great thing about Blue Eyes is they really are quite foolproof. They're quite simple to use. They're very robust. So really, we're just trying to encourage people to use them, not be scared. On the marine biology course, the students have been able so far to use the ROVs to extend their studies of the intertidal zone. So every year there is a trip to the intertidal zone and they look at the species that are living on the shoreline. And having the ROV enables them to continue their transects of what they can see on the beach further underwater. And it also means that they can see intertidal species, but when the tide's in, so how they behave differently when they're flooded as opposed to when they're on the beach. The ROVs were super valuable for a student cruise when we were working with UNIS, the University in Svalbard, where there were postgraduate students on a benthic ecology course. And we were able to take ROVs on that cruise with them, and they were using the video as part of their analysis. They could analyze the images from the ROVs to see what species were living in the various zones in the different fjords at different depths. So that was really useful for them. Blue eyes are great in that you can so quickly have eyes underwater. It's very simple to set up and you can quickly record video, get images of things that normally you'd have to have a lot of faff and put dive gear on, or send a camera down that maybe wasn't real time. Blue eyes are just instant heads-up display of what you're looking at underwater, so really helpful. The biggest difference between Blue eye and other underwater technology that I've used myself is primarily the app nature of it. The app makes things very simple. It makes the connections quite straightforward. Most of the instrumentation I've used in the past has been quite heavy, more programming language to speak to the instruments, usually through a laptop. Whereas the setup on your phone with an app makes it really, really easy. So one of the research projects that we're using the Blue eyes for at the moment is going to be a slow process, but we have a very long time series of photo stations, and those photos have always been taken by divers, and we're working on whether at some point the ROV technology and the image quality from ROVs can ultimately replace diver footage, because they are a lot cheaper than divers. Thanks for listening to me, and good luck with your Blue eyes.
All right, thank you so much, Cedric, for that. We are coming up now on the end of today's webinar. I'd like to take out some time to again really thank the dedicated people of the Blue Eye team. James Nixon, who joined us today live. Tron Larson, who participated in the demo that you saw, and the rest of the Blue Eye team that was not able to join for today's webinar, but are working very, very hard behind the scenes to make all of this content happen. Again, we are running a little bit short on time, but I am going to be going through some of the questions that we see here in the chat. So I'm going to open those up. We have one customer who is talking about the high cost of some of the products that we've been talking about. I love that question, actually. And the reason why I bring that up is because you know, we are platform agnostic, right? And it's why we also love working with Blue Eye, is because they have a wide range of products, excuse me, to fit a wide range of budgets, right? So there's lots of grants that are out there for startups and you know, people that can help in affording this type of equipment. You know, unfortunately, this technology is expensive to make, so it can be a little bit costly, but that does not mean that you don't have access to it. You know, you just reach out to us, and we can try our best to guide you in that mission to gain the funding to bring these tools to your program. So again, thank you so much for that question. Do we accept students or internships, or is there a provision for student bench work in your company? This isn't something that we've explored in the past. We're always open to partnerships. I believe that you actually joined for last week's webinar as well. So thank you so much for your time, both last week and this week. I did send you an email as well, so you should have my information. My information is also displayed on the screen. So if anybody here is interested in partnerships or would like to talk about any product spoke about today or during the rest of our webinar series, again, do not hesitate to reach out to myself either via email at peter@robotlab.com or my cell phone number displayed there on the screen. One last question before we conclude today's webinar. We have all the water we've seen is very calm. What happens when you are in moderate waves? How do you get closer but avoid running into things? And James, I'll let you take that one.
Yeah, absolutely. We do have the benefit here in Norway of having particularly nice water conditions, cold, clear water. We do not have a test tank. We use these things in the real world. Current conditions, the speed at which water flows, are obviously a concern for any type of in-water activity. We have a dead ahead speed of about 3 knots, and we can feel comfortable in working in a 2-knot current. That's a pretty substantial movement of water. In terms of being dirty water or low visibility, if you are currently using some kind of camera to capture images in that setting, I assure you that a blue eye camera is as well suited, if not better suited, to gaining underwater images than the one you're currently using. If it's zero visibility, we have plenty of sonic options, sonar options that can help you move around in zero visibility. In terms of running the ROV into something, we've got that covered too. The lens of the camera is covered by a dome. That dome is surrounded by some impact plastic. So unless you manage to run something the size of this pen directly into that glass, then there's no problem. Feel free to run this thing into flat walls, boat hulls, whatever. The plastic that's there is there for hydrodynamics. It doesn't have anything to do with the functionality of the ROV itself. So what I'm saying is if you have a current method of collecting those images, a blue eye can help you do that. Definitely safer, probably quicker, and we hope more cost effectively.
All right. Thank you so much, James, for that information, and thank you for assisting with that question there. To all of our participants, a vast majority of you have stuck with us from the beginning to the end. I can't tell you enough how much we appreciate your time. I know an hour out of everybody's day, when we don't have enough hours in the day, is extremely valuable, and you've spent that time with us. Thank you, thank you, thank you. Please have a wonderful rest of your day, everybody. Again, thank you to the Blue Eye team. Thank you for Maria for joining us and interacting with all of the folks on the chat. We sincerely appreciate it. None of this would be possible without you. And we hope to see you again next week.